Hello, fourth graders. It's time for lesson 7.10, and we are going to learn just a bit of science here at the beginning about the word calorie. Hey, you've probably heard of this word in terms of calories and food, and what a calorie actually is. It's a measurement of a unit of energy. Okay. And a calorie is the amount of heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius. And so, some foods are going to have a lot of calories, and some foods are going to have a small amount of calories. I just had a granola bar a few minutes ago, and my granola bar on the package said 100 calories. You can look at other items here, like look at chicken McNuggets and fries, 736 calories. Right? That's a lot of calories. So we are going to be, we need this knowledge as we move forward here. Our objective today is going to be to correctly solve some multiple step word problems that include fractions. Okay? And all of these are going to be related to this chart, which is it's kind of like an exercise chart. So I would like for you to open up to Math Journal page 256. And take a look at this chart, because this table shows how long it takes to burn 100 calories during doing a variety of activities. So food has calories, but then when we exercise, we use those calories. Okay. So which activity is the fastest way to burn 100 calories? So look at these. These are all fractions, of course, and mixed numbers, and they are related to time. Okay, so for example, bowling says 1/2 of an hour to burn 100 calories. So that would be 30 minutes. So which of these activities is the fastest way? Look at these fractions and then look at the activity, right? Because if you're going to burn 100 calories, it's going to be a lot of activity, a lot of work. Try to find the one that you think is the fastest. Okay, the fastest way to burn 100 calories on this chart is right here. See where it says 1/10 of an hour, and it goes with running the stairs. Yeah, that's a lot of exercise, isn't it? You're gonna need a lot of energy for running the stairs. So if I thought about that in minutes, let's just go back to that screen. And I thought, well, how many minutes is 1/10? What's 1/10 of an hour? Well, I know that an hour has 60 minutes. So what if I broke this hour into 10 parts? Well, if I'm going to split something, you know what that means, right? If I split it up, I'm going to divide it. How many 10s are in 60? 6. Okay, so you could burn at 1/10 of an hour is 6 minutes. So you could burn 100 calories in just 6 minutes by running the stairs, right? Remember, Mr. White's granola bar was 100 calories. So if I wanted to use up all those calories, I could go run on the stairs for 6 minutes. All right, let's keep going. What about the slowest way? So same kind of question. We want to burn 100 calories, but we want to know the slowest way. So this is going to be something that is not very much activity. I want you to look through here and choose which one you think is the slowest way. It's the biggest number, right? 1/10 here was the fastest way because it was the lowest fraction, right? In order for something to be done fast, it means it doesn't take much time. So the biggest number is right there. And what to go with? Sitting. So if you're just sitting, right? If you're just sitting on the couch or sitting in my chair like I am right now recording this video, it will take 1 2/3 hours in order to burn 100 calories. What a big difference, right? So 1 2/3, well, I know 1 hour. So if I have this 2/3 of an hour, I'm going to think, okay, so 60 minutes, how much would 2/3 of that be? Well, if I had to split this into 3 equal parts, I would divide, and get 20. Now I need 2 of those parts, right? 2 of those 20s. So this is 1 hour and not 20 minutes because that would be 1/3. 1 hour and 40 minutes. If I want to change that all into minutes, I would take this, which is 60, and add it to the 40 to get 100 minutes. Okay, so a long time to burn calories. And that makes sense, right? We talk about that all the time, checking to make sure our answer makes kind of sense in the real world. Well, yeah, of course, running up the stairs is hard. So you're going to be done with calories fast there. Sitting, that doesn't take much effort. Okay, so that's going to take longer to burn those calories. Which activity would burn 100 calories more quickly? Playing catch with a football or singing? All right. So now before we go to that, the fastest one was 1/10, right? The fastest one was 1/10. It was the smallest fraction. The slowest one was the biggest fraction. So we're going to need to look for, in order to know which one was faster, it's going to actually be the smaller fraction, the smaller number, right? When you're looking at speed, if I finish something in 5 minutes and you take 10 minutes, I was faster than you. My time was less. So we're going to look for a smaller fraction. Playing catch with a football or singing? All right, playing catch with a football, 7/12. Singing, 5/6. And so I asked myself, well, which of these is the smaller fraction? Okay, because the smaller fraction is going to be the one that takes less time. There's a couple ways I could do this. I could think about benchmarks, right? 7/12, that's really close to 6/12. And 6/12 is half. Whereas 5/6 is almost the whole thing. So this fraction is going to be our smaller one. Another way to think about this is our equivalent fraction rules. I can multiply the top and the bottom here times 2 and see that this is 10/12. And 10/12 is bigger than 7/12. So the one that is faster has the smaller fraction. So our answer here is playing catch with football. And doesn't that make more sense, right? You would burn more calories faster playing catch with football than singing, right? Singing, you're standing. Okay. How long would it take to burn 200 calories by raking leaves? All right. So raking leaves, 2/5 of an hour. So in 2/5 of an hour, we can burn 100 calories. What if we wanted to burn 200? What do you think we should do? Yeah, we just need to double this, right? If we double this times 2, we keep the bottom number the same. Remember, look at all this. We did these multiplying fractions recently, didn't we? 2 times 2 equals 4. It would take 4/5 of an hour to rake leaves. How long would it take to burn 400 calories by ice skating? All right, go to ice skating here. 3/10. That's for 100. We want to get up to 400. So what do we need to multiply by? Times 4, right? What is 3/10 times 4? It is 12/10 or 1 2/10, which is better, right? 1 2/10. If I wanted to decide that in minutes, well, this would be 60 minutes. 2/10, remember we said that a tenth, if you took 60 minutes and divided it into tenths, into 10 parts, each of those parts would be 6 minutes. So 2 of them would be 12 minutes. Okay, so that's how you can break this apart. All right, there's our objective to solve multi-step word problems, including fractions. All right, on this page, we have some questions here. We have question 1. You're going to do that one, so circle number 1. You're going to do number 2. Mr. White is going to do number 3 with your help. And then you're going to do number 4. So circle 1, 2, and 4. Those are the ones that you have to do today. Let's do number 3, though, together. Taru burned about 1,000 calories downhill skiing before lunch. If she plans to ski for a total of 5 hours today, how many hours will she ski after lunch? All right, let's unpack this. There's a lot here. So the character and what she wants to ski for 5 hours today. So we've got lunch. I'm going to put lunch just right here in the middle because we have some that she did before lunch and some that she did after lunch. She burned 1,000 calories before lunch. 1,000 C for calories. If she plans to ski for 5 hours today, how many hours will she ski after lunch? So we need to figure out how many hours she did before lunch. Okay, that's going to help us out. So we need to know 1,000 calories. How much? We got to find the skiing number, don't we? Skiing, this is going to help us a lot. Downhill skiing, 1/6. So it takes 1/6 of an hour when you're skiing to burn 100 calories. She burned 1,000 calories. So what would we be multiplying here? Yeah, times 10. And times 10 here. What is 1/6 times 10? 10/6 or, right, 6/6 plus 4/6. So this would be 1 4/6. Okay, so this is how long she went skiing in the morning. She wants to ski for 5 hours. Right, so this number plus whatever she skied here equals 5. So we can flip that around, can't we? What should we do now? What should we do now to figure out how much she skied after lunch? We need to subtract, don't we? We do. We need to subtract 5 hours minus 1 4/6. Now, don't forget about this. You can't just say, okay, I'm going to put 4/6 down here. Nope. Not like that, right? Remember, this is the same as 5 0/6. 0 minus 4, we can't do that. So we're going to borrow. We're going to borrow a group of 6. So now here we have 6/6. Remember when we worked on that? See how it all kind of comes together here? And then we subtract and we get 3 2/6 hours, or 3 1/3 if you want to reduce that. All right, those are the steps you're going to go through, right? These are multiple step problems. So you're going to be doing some thinking. You're doing number 1, number 2, and number 4 today. All right. If you need any help or if you have any questions about calories or skiing, well, I can't help you much on skiing or singing, unfortunately. Well, I do a little of my singing, right? My 4 song, my 7 song. If you need any help, let me know. And good luck.